Okie dokie. In this problem, they say, given the following graph, decide which formula best describe it. So the first thing I would look for is the midline of this graph. Like, where is the middle of this graph? Like, what cuts it in half if you were to slice it horizontally, right? So if we have a minimum value each time of negative 1.25, we know that because it's halfway between negative 1 and negative 1.5, right? That grid line. And then it goes all the way up to 0.75. We need to find the halfway point between 0.75 and negative 1.25. Well, hopefully it's clear that it would, I don't know, they're, how am I trying to say this? They're both 1 away from negative 0.25. And so I think it's safe to say that, like, because it started here and ended here, it's, you know, kind of giving you the midline right away. I wasn't sure if that was the case or not, but it definitely is now that I look at it closer. All right, so we have our midline, and the midline is at negative 0.25. Well, the midline should show itself at the end of the equation, because the end of the equation here should tell us how far up or down we are being shifted, or the graph is being shifted. And so if it goes down to negative 0.25 or negative 1/4, that tells us that the equation of the function should end in negative 1/4 or minus 1/4 instead of plus 1/4. Okay, so this number on the end always tells you your midline value. Okay, so now what's the difference between this and this? Let's see. So they both have the 3 in front of the x, except one is just shifted a little bit. And so it might help to recognize that if we think back to our sine function, our original sine function starts at 0, 0, works its way up, then down, then up. But starting at 0, 0 is the key. If there's a shift like this, say plus pi over 2, then say this graph would be shifted to the left by pi over 2, meaning what once started at 0 would be shifted over by pi over 2 and actually start here. And then by the time it goes up, it's probably hitting this and then coming back down and going up like that. So it's shifted left by pi over 2. But on this graph, let's erase some stuff here. It looks like it's still kind of starting at its equivalent for 0, 0. Like it's starting at the midline in the center, something like that. What I'm trying to say is that it's not starting like up high or down low. It's starting right in the middle. So I think it's safe to say it's starting in the middle like the original sine function is, without any shifts. So I don't think a shift horizontally is what we want. I think we just want to leave it right where it is. Okay, hope that made a little bit of sense. I have 3 more. If not, we'll get a little more exposure here. All right, first step, find the midline. Let's see, can we also just use, I don't think it works every time, because this is definitely not the midline of the function. So let's do the method we did in the last one, as best we can anyway. We have this and then that. Well, that's not very helpful, is it? Whew, that's like 0.7. And then this is maybe like negative 1 point, oh goodness gracious, negative 1.3 maybe. And I think they're actually both, wow, they might be 1 away from negative 0.3 each. So negative 0.3 would be right here, I think. It's a little rough, but hopefully you see what I'm trying to say here. All right, so this little midline, so roughly negative 0.3. Negative 0.3 would be our midline. So just by, looking at these values, you can probably tell what they're going for. Probably going for negative 1/3. It might just be easier to say that, like, since you know the function has been shifted down and not up, just go with the negative options. Yeah, let's just leave it simple like that. So eliminate these. And then what's the difference? We have a cosine of x, and we have a cosine of 4x minus 2 pi over 3. All right, so in this case, it's going to be even easier to identify the answer because of the cosine of 1x versus the cosine of 4x. Cosine of 4x is going to speed up this function. In other words, it's going to make it have a much smaller period. The original cosine period is 2 pi. It takes 2 pi from 0 to 2 pi to complete one full rotation. But if you look at this graph, we're going from 0 to 2 pi, and it's completing, let's see, like 1, 2, 3, like almost 4 full rotations and four, sorry, not rotations, but cycles or periods, right? So it's completing 4 periods in the same time it originally completed 1. So 4 periods, this 4 is making it go 4 times faster. That's why its period is 4 times shorter. Hope that makes some sense. Basically, if you see a lot of oscillations, that's how you know there's got to be a multiple in front of the x, as opposed to just cosine of, say, 1x, like that, because you'd see a lot less curvature, a lot less oscillation in that case. Let's do 2 more. All right, I think this is a pretty similar example. Hopefully it's clear that this has been shifted down a little bit. This might be almost the same one. I think this is the same one we had. Maybe I brought it in on accident. I don't know. Let's see. So it's been shifted down slightly. And so we know it's not plus 1/4 on the end since it's been shifted down. And then between sine and sine here, let's see. We have the 3x, we have the 3x. I think it's the same exact one, right? Because it's starting still at 0, 0. So we know there's no phase shift, there's no horizontal shift. I'm going to go with A again. I think it's the same exact one. I don't know if that was a coincidence or not. Let's do the actual last one we have. Sorry about that. All right. So clearly you can see there's barely any periods, any oscillations going on, right? So I'm assuming there's not going to be any big multiples in front of the x terms here. So with that in mind, we can see that the max is like maybe 0.8 and then the min is negative 1.2. So you can tell there's been a shift just barely downward. So we can get rid of any answers that are adding a vertical shift, like, a vertical shift up. And then we're, down to this one and this one. So then we have cosine of 3x. Again, cosine of 3x would indicate that you should probably see at least 3 periods of this function being completed, 3 cycles. But in this case, we do not. We only see 1 period of this function. So it's our original cosine function really just shifted down by 1/6. That's all there is to it. Hope that makes some sense. Hopefully this sheds some light. Obviously, this probably is not the full scope of different types of problems you'll see in this problem type, but hopefully it gives you enough information to identify answers and, to apply things to other problems that you haven't, that I didn't cover, I guess. Hope that makes sense. If you have any questions, let me know, or send problems my way, whatever you want to do. All right.